Hello, and welcome to the sleepy universe. Tonight, you will drift through time, not as a line, but as a breath, soft, rhythmic, and infinite. You will explore the quiet seams between past and future, where the present stretches wider than you imagined. In this gentle journey, time won't chase you. It will unfold around you, like a warm tide, like a dream you don't need to wake from. Close your eyes. Let's begin where tomorrow waits inside the now. You lie on your back beneath a sky so wide it seems to swallow thought. And above you, the stars shimmer like distant, forgotten fires, each one a lighthouse flickering across the tides of space. But the more you gaze, the more you sense that not all light is equal. Some stars pulse gently, others burn steadily, and still others flicker as if something has passed in front of them, like a secret kept only in shadow. To the unaided eye, these stars are simple points, but in truth, they are storytellers, each one humming a quiet tale across time. You imagine that hidden behind the constancy of their glow are companions, small, dark worlds slipping silently across the stellar face. These are the ghost lights, planets that do not shine but pass like whispers in the night. You are not the first to wonder what lives beyond this sky. For centuries, the human heart has stretched its curiosity outward from the ground of Earth into the endlessness of space. But only in recent decades have we learned how to truly listen. You breathe in the silence and let your thoughts follow the work of astronomers who stare not at stars, but at their faintest dimming, searching for patterns in the loss of light. This is the method of transits, a cosmic shadow play, where a planet crossing a star causes a tiny dip in brightness, like a speck of dust briefly crossing a beam of light in a darkened room. That dip might only last a few hours and dim the star's light by less than 1%, yet within that shadow lives the echo of a world. You learn to imagine what those dips mean, how large the planet must be, how far it orbits, whether it's baked by starlight or wrapped in cool darkness. Each transit is a kind of heartbeat, repeating in rhythm with the planet's orbit. And from those pulses, scientists build portraits of faraway places they will never touch. You think of Kepler, not the old mathematician now, but the telescope. Named for him, a silent sentinel launched into orbit, eyes always open, staring at over 150,000 stars for years, waiting not for motion but for stillness. It found over 2,000 confirmed exoplanets, and many more possible ones, all by watching the same patch of sky, patient as a stone in a river. Some of the planets it discovered were hot giants that hug their stars in dizzying speed, orbiting in days. Others were Earth-sized and quietly tucked in the gentle warmth of their stars, habitable zones, that delicate distance where liquid water might exist, where life as we know it might cling to rocks, to clouds, to dreams. But you learn quickly that detection is only the beginning. Every star flickers for reasons of its own magnetic storms, flares, or age-old cycles, and sorting real planets from noise is like trying to hear a single flute in a forest filled with wind. Scientists comb through data like monks through scripture, looking for that quiet consistency, the dip that comes back again and again, always at the right time, always the same shape. You find this process strangely comforting, a reminder that meaning can emerge from noise, that certainty can grow from shadow. You think of the stars above you, not just as lights, but as wells of gravity, each one holding a family of worlds that we cannot see, yet now know must be there. Over 5,000 exoplanets have been confirmed as of now, and likely billions more await. They orbit red dwarfs, yellow suns, and even dead, white remnants of long exploded stars. Some are puffed up gas giants made of cloud and wind. Others may be rocky, with surfaces that crunch underfoot if foot could ever touch them. A few may have oceans deeper than Earth's crust, or skies laced with methane, or rains made of glass. But some, just some, may be familiar, temperate, blue. You let your mind drift to these maybe Earths, not because they are likely, but because they are possible. And possibility, after all, is the thread science dreams upon. Each new detection, each quiet light curve is not just a planet, it is a chance. A chance to find not aliens, perhaps, but echoes. Echoes of chemistry, of climate, of the slow ancient game of time and sunlight. The ghost lights of the sky become less ghostly, more real, as you learn about the ingenuity that lets us detect them. Beyond the transit method, there is radial velocity, a technique that listens to the stars wobble, caused by the tug of an unseen planet. You imagine that motion, tiny and graceful, like a star dancing with an invisible partner. Then there's direct imaging, a method so difficult that it requires blocking out the star's light, like trying to photograph a firefly beside a floodlight from miles away. But even that has been done. You marvel at how far human perception has stretched from seeing only the moon and planets of our own solar system to finding evidence of distant orbits around stars that themselves lie light years away. These aren't mere speculations anymore. They are measurements, patterns, models. They are real. And so you lie beneath the stars again, only now your gaze has changed. That simple glint in the sky might not be just a sun, but a solar system. It might be a home. You begin to sense the loneliness of the cosmos, not as a void, but as a field full of unopened letters, each planet a sealed envelope carried on the back of light. What would it mean to open one? To understand its air, its seasons, its chemistry? What would it mean to be watched as we watch? For now, the planets remain silent, their orbits steady, their shadows soft. But the act of noticing them has changed you. You become aware of how your own planet must look from afar, crossing a small star, a faint dip in someone else's sky. And you wonder who might be watching Earth, wondering if its dimming means life. You realize that discovery isn't just about seeing new things, but about seeing old things differently. The stars above you are not fixed. They are stages, and the show has only just begun. In the quiet of your thoughts, with eyelids heavy and breathing slow, you let go of the earth a little. Not to leave it, but to join a larger thought. You drift, not outward, but inward, toward a question that gently opens in your mind. If the planets we see are only those whose orbits align just right, how many others slip by unnoticed, invisible in their perfect timing? And if so many remain hidden, what else are we still blind to? You begin with a beam of light, gentle and unwavering, falling across your skin like a whisper. It feels simple, warm and clean, yet light, as you soon discover, is not a simple thing. It is a language, a song, a map. It carries the memory of where it has been, the temperature of the stars it touched, the chemical breath of the worlds it passed. Light does not merely shine, it tells. And so tonight, you close your eyes not to block it, but to listen. Light travels fast, but never forgets. When a photon leaves a star, it begins a journey that could stretch across millennia. Some rays take 8 minutes to reach Earth from the sun. Others have wandered for 1 billion years before finding your telescope. You imagine them as messengers. each one shaped by the fires that birthed them, the clouds they slipped through, the gravity that bent their path. When you see a galaxy, you are not seeing it now. You are seeing it then, a moment, in its ancient past, delivered by the faithful courier of light. This is the truth that softens your breath and slows your heartbeat. Every star you see is a memory, not a presence. Every bright speck in the sky is a ghost, but a ghost that speaks. Scientists have learned how to read the message hidden in each beam. They use instruments called spectrographs, which split starlight into its colors, stretching it like a rainbow laid bare. But unlike the rainbows you see in the sky, these rainbows hold gaps, thin black lines, missing pieces. These are absorption lines, and each one tells a tale. When light passes through gas, certain wavelengths get absorbed depending on the elements it meets: hydrogen, helium, sodium, oxygen, iron. Each element leaves its signature, its absence. It is a strange magic. By not being there, something reveals itself. You learn to think of light not as a glow, but as a sentence written in invisible ink. With every spectrum measured, scientists decode the makeup of stars, the speed of galaxies, the composition of alien atmospheres. You begin to picture the sky not as a canvas of light, but as a vast conversation full of pauses, hesitations, and inflections. Light lets us measure distance, too, though not in steps or miles. It tells us how far a star has wandered by how much its spectrum is shifted. If a galaxy is moving away, its light stretches redshift. If it's coming closer, the light compresses. Most galaxies, you learn, are redshifted. Almost all of them. That means the universe is expanding, breathing outward in all directions. This isn't just theory, it is seen in light, again and again. Every beam carries the shape of motion. The faster the galaxy retreats, the more the lines shift. The farther it is, the more stretched its light. In these tiny tugs and pulls, the cosmos reveals its dance. You begin to feel small, but not in a fearful way. Small like a note in a symphony, part of a pattern. As you drift deeper into the quiet of your imagination, you begin to wonder about the planets we cannot see, but whose atmospheres we can taste through light. When an exoplanet crosses its star, a little starlight passes through its atmosphere. That light changes. It carries the fingerprint of gases, water vapor, carbon dioxide, methane, maybe even oxygen. This is how we will one day recognize a living world, not by seeing its mountains or oceans, but by reading the trace of breath in the way light bends. Even now, astronomers are collecting these faint spectra from planets dozens, hundreds of light years away. You find it humbling that a beam of light, softened and filtered through a distant sky, can cross the cold silence of space to tell us what air tastes like on a world we will never touch. You think of light as gentle, but it can also break things apart. Ultraviolet light from stars can strip atoms from molecules, carve paths through clouds, burn through dust. It shapes planets, sculpts atmospheres, feeds life. On Earth, it energizes plants, paints colors, ignites skin into warmth. In deep space, it carves dark nebulae into glowing edges, pushes on comet tails, heats the surfaces of airless moons. You realize that light is not passive, it acts. And so every beam that reaches your eye or camera is a survivor, a beam that passed through filters of space and time, shaped by forces you can only imagine. You picture the James Webb Space Telescope, floating far beyond the reach of Earth's blur, staring deep into the past by catching the faintest infrared light. warmth really stretched and cooled by distance. It looks at the universe not as it is, but as it was when it was young. The first galaxies, the first stars, the first dawn. And still, it uses light. Always light. The same tool used by Galileo, by your eye, by your dreams. You begin to think of your own body as part of this system. The rods and cones in your retina, the optic nerve, the patterns in your brain, all evolved to catch and interpret light. Evolution made you a light reader, a color decoder. When you see a sunset, when you notice a candle flicker, when you glimpse the shimmer of a beetle's wing, you are interpreting electromagnetic waves with ancient biology. Your brain turns vibration into vision, and in doing so, it turns waves into meaning. The poetry of light becomes internal. And so, as you lie still, breathing deeply, your mind turns again toward what you cannot see directly. There are forms of light your body cannot sense, radio waves, X-rays, gamma rays. But machines can. Telescopes across the world, and above it, listen in all frequencies. A black hole may be invisible light, but its X-rays scream. A neutron star may be dark to your eye, but its radio pulses stutter like a cosmic clock. Light is not limited to what you see. It is a symphony in many octaves. You learn that astronomers build pictures of galaxies not from photographs, but from layers of light in different forms. An image of a spiral galaxy might be colored in blue to show hot. Young stars, red to reveal dust, green to highlight gas. These colors may be false, but the information is real. Light carries structure, temperature, density. It reveals bones beneath the sky's skin. You return to your breath, long and slow, and think how this changes the way you look at a sunrise, or a flashlight, or a starlit path. Every beam is a thread connecting space to your perception. And in the quiet, you wonder if light can tell us so much about composition. Temperature, speed, distance, atmosphere, what can't it tell us? Is there a deeper kind of darkness, one that even light cannot touch? Could there be truths, hidden not behind stars, but behind the limits of light itself? You let that question float, unhurried, as your thoughts prepare to meet something stranger, not just light that reveals, but gravity that bends what light can say. You do not feel gravity, not directly, you feel only its consequences. The weight in your limbs, the curve of your spine against the bed, the way your breath settles rather than floats, all of it is gravity's signature. But tonight, you lift your mind away from Earth's familiar tug and stretch your thoughts across the cosmos, where gravity leaves gentler fingerprints, not in weight, but in shape, in silence, in time. You begin with the understanding that gravity is not a force in the way you once thought, not a string pulling, not an invisible hand. Instead, gravity is the bending of space and time itself, curved gently by the presence of mass. Picture a soft sheet stretched taut. A marble placed on it creates a dip, a gentle curve. A second marble placed nearby will roll toward the first, not because it was pulled, but because the fabric beneath it tells it to move that way. This is gravity, not demand, but suggestion, not force, but geometry. And just like the marbles, planets orbit stars not because they are yanked into place, but because space-time has told them this is the natural path. You imagine Earth wrapped in a subtle valley of bent space-time, turning not in defiance of gravity, but in perfect agreement with it. Every motion you know, every orbit, every fall, every tide, is not a reaction to pulling, but a dance within a curvature. Gravity is not loud, it whispers, and it touches everything. Your body, your heartbeat, the flight of birds, the turn of galaxies, all of them shaped by this silent influence. But it is out in deep space, among vast masses and empty stretches, where gravity reveals its most elegant art. There, in the distant reaches, it sculpts galaxies like pinwheels, each star flowing along paths carved not by hands but by the shape of space-time itself. You learn about gravitational lensing, one of gravity's most delicate fingerprints. When light from a distant galaxy passes near a massive object, another galaxy, a cluster, even a black hole, the light bends, but it doesn't shatter. It curves around the mass, like water flowing around a stone, and continues on its way. By the time it reaches your eye, the light may appear distorted, stretched, duplicated, even ringed around the object it passed. These are called Einstein rings, and they are real, not imagination, not illusion. You are seeing gravity's trace. It's as if the universe, in places, becomes a lens bending space to magnify the secrets behind it. This bending does not distort truth, it reveals it. It allows astronomers to see galaxies otherwise too faint or too far. Gravity becomes a tool for vision. You begin to picture the universe not as a flat map, but as a vast, rippling landscape. Every star, every planet, every cluster leaves a dent, a curve, a wrinkle. Some are shallow, like footprints in dust. Others are deep, like whirlpools in the ocean. Black holes leave the deepest wells. And if gravity can curve space, it can curve time. This is perhaps the most disorienting truth. Time runs slower where gravity is stronger. A clock near a massive object ticks more slowly than one farther away. The effect is small on Earth, but measurable. Your GPS works only because its satellites account for the difference in time between their weaker gravity and your stronger one. But near a black hole or a neutron star, the difference becomes profound. You imagine hovering near such an object where time slows like thick syrup. Minutes, for you, could be hours, years, millennia elsewhere. Gravity does not merely shape where you are, it shapes when you are. The universe is not synchronized, it flows in uneven tempo, like a symphony with shifting rhythms. You wonder, then, how this shapes memory, how it shapes light. If time slows near mass, then light emitted from that place is redshifted, stretched, cooled, gentled. This gravitational redshift is yet another fingerprint, and scientists can read it carefully, tracing how deep gravity curls time before letting it go. You drift deeper into thought. Gravity waves, not metaphorical, but real, ripple outward when massive bodies move with sudden force. When black holes spiral together and merge, or when neutron stars collide, they send out waves not of light, but of space-time itself. These waves stretch and squeeze the very fabric of existence, and here on Earth we have learned to feel them. The LIGO and Virgo observatories, vast arms of laser silence, have caught these ripples as they pass through, tiny tremors in a calm sea. The shifts they measure are smaller than an atom, yet they carry the story of monstrous events from galaxies away. You realize you are living in an era where even the fabric of reality can speak, and we have begun to listen. You think of gravitational equilibrium, the balanced places in space called Lagrange points, where the gravity of two massive bodies, like Earth and the Moon or the Earth and the Sun, cancel just enough to hold something in place. These are quiet places, restful zones where satellites can float with minimal fuel, where balance becomes a location. Gravity isn't always pulling. Sometimes it pauses. It allows stillness. It allows orbits not as prisons, but as gentle rests. In these places, we place telescopes. We listen from stillness. You return to Earth in your mind, now changed in scale, aware that gravity holds not just our bodies to the ground, but the air around us, the oceans to the shore, the moon. In its dance, you see it in tides and eclipses, in the tilt of seasons, in the arc of thrown stones, and in the soft weight of your own head on the pillow. You remember Einstein's revelation that acceleration and gravity are the same thing, that falling feels like floating, that being at rest in gravity feels like being pushed by speed. The universe hides its simplicity in layers. You realize that gravity connects everything, not just by direction, but by influence. You are held not just to Earth, but to every star, every galaxy, every mass that has ever existed. Force gets weaker with distance, but never truly ends. You are tied by invisible threads to the entire cosmos. And if gravity is memory, the memory of mass bending space, then perhaps the universe remembers not just where things are, but how they moved. Perhaps every gravitational wave is a whisper of history still passing through us. You imagine lying still while ancient waves, the aftermath of collisions that happened before Earth was born, wash over your room, your bones, your breath. Gravity is not just down, it is everywhere. And now you wonder, if gravity bends, time and waves ripple outward through space-time, then could the future feel us too? Could there be waves we haven't made yet? There is a silence in speed that no wind can touch, a stillness that lives not in stopping, but in going so fast, the world itself begins to change. Tonight, you turn your attention to the edge of that silence where time begins to falter. You are not racing forward, but gently drifting into the laws of relativity, where speed does not simply carry you across space, it carries you through time, differently, unevenly. You've felt this before, lightly, in metaphor, the idea that time flies when you're busy, that it slows when you wait. But tonight, you feel it in your body, in physics, in the truths that do not change when you close your eyes. Time, you learn, is not a constant drumbeat echoing through the universe. It can stretch and compress depending on how fast you move. This idea, first dreamt into numbers by Einstein, becomes a quiet revelation when you picture it not as math, but as breath. When you move slowly, time moves with you. But when you begin to travel near the speed of light, not metaphorically fast, but truly fast, unimaginably so, time itself becomes reluctant. It stretches, it slows, and you, the traveler, begin to drift through a different rhythm, too. An outside observer, you appear in slow motion. Your clock ticks more gently. Your heart pulses with wider pauses. You do not feel it from the inside. To you, time feels unchanged. But the world outside, the stars, the planets, the years passing on Earth, they blur, they race. You are in motion, not just through space, but through time itself. This is time dilation, a whispering effect of special relativity. You picture yourself in a spacecraft, gliding toward the edge of light speed. The cabin is quiet, filled with silver reflections and humming panels. You see stars outside, not as fixed points, but as smears of light bending inward. Your body feels the acceleration, not as force, but as perspective. The faster you go, the more the world changes around you. If you were to return, even after A short journey, you would find time had passed differently for those who stayed behind. A minute for you might be an hour for them, or a year, or a century. You become a traveler of time, not just distance. You think of the famous thought experiment, the twin paradox. Two siblings, one remaining on Earth, the other taking a near light-speed journey. When the traveler returns, they are younger than the twin who stayed. This is not science fiction. This is what the universe actually does. It bends its rules. For speed, it stretches time like soft clay, pulling it thin or compressing it tight. The faster you move, the more the future runs ahead of you. And so, in a way, speed becomes a kind of telescope, not into space, but into time's layers. You ponder the astronauts aboard the International Space Station who orbit Earth at thousands of kilometers per hour. The difference in their aging is minute but real. They live a fraction of a second longer than those on Earth, not because of magic, but because of motion. Gravity also plays a part, another layer of time's bending. But tonight, you focus on velocity, the sheer quiet power of fastness. You float in this thought. Time is not the same for all. It is not a universal metronome. It is a field, a slope, a path shaped by where you are and how fast you move. The faster you go, the more you stretch time behind you. You imagine being aboard a spacecraft that travels to a distant star system, perhaps Proxima Centauri, for light years away. If you could reach near light speeds, your journey would take only a few years from your point of view. But when you returned to Earth, decades might have passed. Generations. The trees would be taller. Children would be grown. The world would no longer recognize your name. You would have passed through time like a thread through fabric, pulling the past behind you, piercing into the future ahead. You feel a sense of awe and melancholy in this thought. Time dilation is not just a scientific curiosity, it is a separation. It is the gentle pain of distance, measured not in kilometers, but in heartbeats missed. But it is also a gift, a reminder that time is not rigid. It breathes, it responds. It allows motion to bend it. And if time can stretch, so can possibility. You let yourself imagine again, not the speed of spaceships, but the inner speed of particles. In laboratories, physicists accelerate protons to near the speed of light. These particles live longer than they should, not because they are changed, but because time stretches for them. Even subatomic decay obeys the universe's rule. Move fast, and time listens. You picture cosmic rays, high-energy particles from space, colliding with our atmosphere. They travel vast distances at unimaginable speeds, their inner clocks slowed by their motion. They arrive on Earth like ancient messengers, old yet untouched. And you, lying still, feel the poetry of this bet. Somewhere, even now, a particle is skimming the edge of time's river, slipping through space while the rest of the universe hurries ahead. You return to Earth again in your thoughts. You remember that GPS satellites must account for both speed and gravity to work. Their clocks, ticking slightly faster or slower due to motion and orbit, must be corrected so that your phone knows where you are. Without understanding time dilation, the modern world would be lost. Your navigation depends on the soft bending of time. You find beauty in this, that every moment you follow a map, every step you trace on a screen is touched by relativity, by Einstein's insight, by the universe's quiet rule that time does not tick the same for all. You feel a closeness to the sky now, not in distance, but in rhythm. You are not isolated from the stars. You are part of the same tempo, even if yours moves slower, faster, differently. Time is personal, and yet it touches everything. It's the pulse of the cosmos, the silent clock in every motion. You drift in thought to a paradox. What if one could move so fast that the future unfolds in the blink of an eye? What would it feel like to step into tomorrow, not by waiting, but by traveling? Would you lose something or gain it? Would the world you return to feel like home or like history? You let the questions remain. They are not meant to be answered, only felt. And as your body rests, you realize time is not simply passing. It is a landscape, and speed, true speed, lets you explore its curves. You are not just watching seconds fall like sand. You are part of time's shape, its bending, its breath. And now you wonder, if speed can stretch time, then can stillness do the opposite? Could standing perfectly still, in a quiet place, allow you to feel the full weight of each moment? Could the now expand until the past and future become thin and transparent around it? You lie still, surrounded by silence, and yet, within this pause, lives everything. The present moment, so thin it can hardly be held, unfolds beneath your awareness like a hidden ocean. You feel your breath, not just as air, but as time's own ripple through your body. You begin to wonder what lives beneath the now. Not behind it, like memory, nor ahead, like anticipation, but beneath it, like structure, like root. You drift downward through thought, peeling back the present like layers of translucent silk. The now you experience, this thin flicker between what has happened and what will, is not a point. It is a width, a whisper, a vibration stretched across tiny intervals of awareness. Science tells you that your mind, your senses, your brain's own machinery, take time to catch up with what's happening. By the time you become aware of this moment, it is already slightly in the past. You are always a breath behind reality, walking through the echo of what just was. But somehow, that echo becomes your home. It becomes your now. And so you live in a time that is real to you, even if the universe has already moved on. There is comfort in this delay. The brain smooths and knits together the rush of signals, visual, auditory, physical, into a seamless experience. A kind of gentle lie that becomes your truth. You imagine peeling back this illusion. You see how signals from your eyes take milliseconds to reach the brain, how touch, depending on where it occurs, may take longer to be felt. Your conscious mind is not riding the leading edge of time. It is trailing, like a candle flame flickering behind the wind. Beneath the skin of the present lies latency, soft, natural delay. And below that there is integration, your brain gathering multiple moments and stitching them into what feels like a single instant. The now you know is already a story told from fragments. But deeper still, beneath perception, is the realm of the atomic, the physical present, as it exists regardless of your awareness. At this level, moments are governed by quantum rules, where particles exist in clouds of probability, not certainty. An electron is not here or there until something asks it to decide. Time at this level does not flow as you know it. It dances, it waits, it becomes tangled. The atoms of your body, even as you lie still, are vibrating, moving, shifting, not in rhythm, but in endless subtle disarray. They do not know of seconds or hours. They only follow energy, interaction, chance. And still, somehow, this quantum chaos builds the warm now you feel. You imagine shrinking, not just in size, but in temporal scale, until you hover at the edge of an atom. Time here feels granular, not smooth. It jumps, it winks. It does not flow like a river, but flutters like the wings of unseen insects. And you begin to understand that the now is not a place, it is a range, a smeared space between events, within which your mind writes its music. But if the present is a span, not a point, then what lives at its edges? Perhaps memories are just cooled moments still within reach. Perhaps the future is already curling its fingertips into the now's outer skin. Neuroscience tells us your mind is predictive. It constantly forecasts what will happen next based on what it has seen. Before, it fills in missing pieces. It guesses, corrects, adjusts. Your now is part memory, part forecast, wrapped in a moment of belief. The world you experience is not raw data. It is interpretation, smoothed and arranged into coherence. Even your vision lags slightly behind your movements, yet you do not see delay. You see the world as whole, stable, alive, beneath the skin. Of the present is a machine of meaning-making. The brain does not merely observe time, it composes it. And it composes it differently when you're alert than when you're dreaming. In dreams, the now stretches, collapses, loops. A second can hold a lifetime. A story can end before it begins. This suggests that time, as lived, is flexible, not by physics, but by perception. Your consciousness is not anchored to real time. It swims in its own currents. And so, even now, as you listen and drift, your sense of time is slowing. This very moment, stretched by calm, by focus, by imagination, becomes wider. You are floating inside the now, not merely watching it pass. This is the miracle of attention. It allows you to open the present like a door, to step through it, to walk its corridors. You begin to wonder what would happen if you could stay inside this wide present forever. If the past were forgiven and the future hushed, and only now remained full, unfolding, endlessly slow, would it be peace, or would it be stasis? Would it be silence or song? Beneath the skin of the present lies not just time's structure, but time's invitation to feel, to notice, to belong. Even physicists, in their cold equations, now ask what the present truly is. Some theories suggest the now is an illusion, that past, present, and future all exist equally, like pages in a book, and we are simply reading them one at a time. Others suggest the now is special, that it is being created fresh with each passing second, like a wavefront across the ocean of space-time. Still others believe time may emerge from something deeper. Entanglement, complexity, change itself. You do not need to decide. You only need to feel the question like a soft pulse beneath your fingertips. If the present is built from fragments of perception, filtered through memory and prediction, carried by electric pulses and quantum dances, then what does it mean to live fully in the now? Perhaps it means awareness, not of control, but of presence, not of holding the moment, but of being held by it. You are not outside time, you are made of it. Your body is a clock of shifting rhythms. Your breath is the tide of seconds. Your thoughts are the weather of moments. And so, even as time seems to pass, the present continues to bloom beneath you, not as a line, but as a garden. You can only see a few flowers at once, but the field is wide. And in this stillness, you realize something unexpected. The present does not just contain you, it also watches you. Time, for all its mystery, is a witness. Every motion, every thought, leaves its mark somewhere, in memory, in entropy, in records etched into the cosmos. The now is not merely happening, it is being noticed. And suddenly, you wonder if time is watching, then who or what is watching time? You are floating now inside the slow breath of time, but something tugs at your thoughts like the gentle pull of an unseen tide. If time stretches, bends, and breathes, if it unfurls and recoils, pulses and pauses, then who or what sets its rhythm? Who is holding the clock? Not the ticking device on your wall or the quartz oscillator in your phone. Not even the perfect cesium atoms vibrating inside atomic clocks. You feel the question rising not from curiosity alone, but from the deeper part of you that yearns to know whether time is truly a river you drift in, or something shaped by invisible hands. The universe, it seems, has many clocks. Some beat fast, like the trembling decay of unstable particles, while others move slow, like the rotation of galaxies. Yet time is not measured by just one rhythm. It is marked by change, by motion, by decay, by cause and consequence. The earth spins, that gives us day. It orbits the sun, that gives us year. The moon drags the tides, that gives us rhythm. But beneath all these cycles, what truly defines a second? You drift into the silence of fundamental physics. In 1967, scientists defined a second as the time it takes for a cesium-133 atom to oscillate. 9,192,631,770 times between two energy levels. That's the heartbeat of modern timekeeping. Unimaginably precise, invisible, and yet trusted enough to coordinate satellites, financial systems, and even the beat of your digital world. But this too is a convention. It is not the reason. Time flows. It is merely a way to count the flow. So again, you wonder, who is holding the clock? General relativity whispers an answer, soft and strange. According to Einstein, time is not separate from space, it is braided into it, forming space-time where gravity is not a force, but a curve. Time passes differently depending on where you are and how fast you move. A clock placed closer to a massive body, a planet, a star, a black hole ticks more slowly than one further away. You imagine this now. Two identical watches, one on Earth and one floating far above it. The one above runs faster. Time itself is stretched by mass. Gravity doesn't just pull matter, it pulls time. And so, the clocks of the universe are not synchronized. Every object holds its own local time. This means that even your own body, tall as it is, experiences a tiny difference in time between your head and your feet. You are a living gradient of time. You wonder then, is the clock held by gravity, by curvature? Does the shape of the cosmos dictate its rhythm? Or is it motion that commands the tempo? Special relativity speaks next. If you move faster, time slows down, not from illusion, but in reality. An astronaut traveling at near light speed would age more slowly than someone left on Earth. The faster you go, the longer your seconds become. At the speed of light itself, time halts. Light, in its own frame, does not age. A photon born in the heart of a star, and one that touches your eye 1,000 years later, experiences no time at all. You breathe in this strange truth. Time is not a constant drumbeat. It is elastic, is responsive. It yields to mass and motion. The clock is not held in one place. It is woven into the journey. You begin to see time as not one river, but many streams, all flowing at slightly different speeds, converging and diverging in the landscape of the universe. What then holds it together? What gives us the illusion that it's consistent, reliable? Shared entropy offers its hand. Entropy, the measure of disorder, is the arrow that points time forward. From cold to warm, from order to chaos, from low entropy to high. A broken glass doesn't unbreak. Smoke doesn't return to a matchstick. Entropy increases, and with it, so does the sense of time moving in one direction. This is not a mechanical clock, but a thermodynamic truth. You begin to realize time may not be held by any single thing, but rather revealed by change, by irreversibility, by the flow from what was to what now is. Still, something deeper stirs, because entropy only describes the direction of time, not its pace. What gives rhythm to the tick? What gives duration to the now? Some physicists propose that time may not even be fundamental, that perhaps it emerges from relationships, from entanglements, from information flowing between particles. In this view, time is not something that exists on its own. It arises when one thing can compare itself to another. The moment when an electron interacts with a photon, that is when time matters. You are no longer asking who is holding the clock. You are beginning to understand that maybe there is no one holding it. Maybe the clock is built from everything, from interaction, perception, memory, and motion. Maybe time exists because things change, and change exists because time allows it. You recall experiments where atoms are placed in perfect isolation. No light, no heat, no interactions. In these rare cases, without interaction, the atoms stop ticking. Not because time stops, but because nothing is there to measure it by. A clock that isn't looked at is no clock at all. You feel the edges of the now press gently inward. You wonder, does time exist where nothing watches, where nothing feels, or moves, or decays? Is time something we participate in, or merely something we endure? You return to yourself, your breath slow and even, your heart beating in rhythm, your thoughts trailing like ripples across a quiet lake. You are a clock, not just in body, but in mind. You remember that your brain has its own timing systems, neurons that fire in oscillations, brainwaves that synchronize to rhythms, time. Perception is built from these pulses, from circadian rhythms, from dopamine levels, from memory encoding. A moment filled with novelty feels longer than one that repeats. A moment spent in awe feels slower, wider, deeper. You realize your experience of time is deeply personal. It bends not just to gravity or speed, but to emotion. A joyful second lingers. A painful hour flies. The brain does not measure time in seconds. It measures it in significance. You begin to understand that maybe time is not held by physics alone, but also by meaning. That we are not just riding time, but shaping it with our choices, our attention, our wonder. And suddenly, you feel less like a passenger and more like a participant. The clock may be woven into the cosmos, but it ticks most clearly when it echoes in you. Perhaps this is the answer to the question you carried here. Who is holding the clock? Maybe the universe is. Maybe gravity is. Maybe light and mass and entropy conspire to trace the hours. But maybe, too, the clock is held by consciousness, by the one who watches, who remembers, who wonders. And if that's true, then every heartbeat, every breath, is not just a measure of passing time, it is a creation of it. You rest in this idea as softly as a leaf resting on water. Because if you are holding the clock, even just a little, then how you hold it matters. How gently, how attentively, how lovingly. And just before sleep takes you, you begin to ask, if we hold time within us, if we can stretch or slow it with meaning, then can we ever touch its beginning? Before clocks, before stars, before space itself could unfurl its wings, there was a moment or something like one when time itself began. Not began like a sentence begins, or like dawn peeks over the curve of earth, but began as in there was no before it. You float now toward that softest edge, the trembling horizon where being and not being press against each other. In your mind, you drift back not through days or years, not through calendars or cycles, but beyond all rhythm, beyond all reference. The universe is not yet a place. It is not dark or light. It simply is potential, a silence waiting to be stirred, and then something expands, not into space, but as space, not through time, but as time. The Big Bang is not an explosion, not a fireball, not a boom, but a becoming, a blooming of reality itself. In that first instant, time is born not as a ticking clock, but as a dimension unspooling alongside the newborn cosmos. You imagine it now not as a bang, but a breath and exhale from a singularity that was never truly a point, but a mystery. Cloaked in math, this singularity, if it existed, contained no space, no direction, no time, no memory, just potential tangled tightly, impossibly dense, curled into itself like a secret waiting to speak. When the universe begins to expand, time begins to move. But what does it mean to begin when time itself is the thing beginning? You float in this paradox, like a leaf on still water. The equations whisper that time started at zero, that the fabric of space-time was stitched into being in that very first tremble. But what does zero mean when there was no before to measure it against? You can't step outside the universe. To see it from the outside, there is no outside. The stage and the story arrive together. It is here that you understand. Time is not added to the universe like a layer of frosting atop a cake. It is baked into the recipe. Time and space are one dough, kneaded by gravity, leavened by expansion, shaped by energy. In the early seconds, we can call them that the universe is hot, thick, and wild. Quarks swirl like dancers in a furnace. Photons scatter endlessly in every direction, unable to travel freely. It is chaos, but it is organized, chaos governed by laws that somehow already know how to behave. And time, still young, flows differently than it does now. It stretches fast, because space is expanding fast. You remember that time is measured by change, by ticking, by repetition. But in this early fire, no atoms exist, no clocks can tick, no stable rhythms have formed. For a long breath, the universe holds no structure, just particles, colliding and parting, building and breaking. Eventually, things cool. Electrons find nuclei, atoms form, light finally travels freely, and the cosmos becomes transparent. This is when the universe becomes visible not only to telescopes, but to itself. You sense something important here. Time is not just passing, it is shaping. As things cool and organize, time becomes meaningful. Before, there was only becoming. Now, there is memory. You wonder what it was like for that first photon to travel in a straight line, unhindered, across the vastness of a newly opened sky. Perhaps, in its frame of reference, no time passes at all. But from our view, it is the beginning of history. The first light, the first path, the first record. This light still echoes today, not as brilliance, but as a soft, cold hum, a cosmic microwave background. A whisper from the moment time began to truly flow in a way we can measure. And so, the birth of time is not a single flash, but a gradient. A slow awakening. At first, too hot to hold memory. Then, cool enough for particles to assemble. Then, dark and quiet for billions of years as gravity sculpts the first stars. And finally, bursts of light again, as stars ignite and galaxies swirl into being. You begin to feel time not as a thing separate from matter, but as a byproduct of interaction. Without things changing, time is meaningless. Without clockspeed, they atoms or galaxies, there is no tempo. Without memory, there is no history. And yet, from this deep simplicity, all complexity rises. You begin to realize we don't merely live in time, we are expressions of it. Your cells divide in rhythm, your thoughts unfurl in sequence. The warmth you feel now is not just heat, but time made tangible, light from stars, long dead, finally reaching your skin. You are a product of this unfolding, and in you, time has found a mirror. But where did time truly come from? Could it have existed before the Big Bang? Some theories whisper of a before, of a timeless quantum foam where fluctuations might bubble universes into being. Others suggest that time is cyclical, that this universe is one breath in a long inhale and exhale across cosmic eons. Still others say that time as we know it is an illusion, that the laws of physics are timeless, and that change is a trick of our perception. These are ideas without confirmation, but still they stir something in you, or you are not here to solve the mystery, but to hold it gently in your thoughts. You rest in the strange comfort that some questions are meant to cradle us, not cage us. Because even if time began at the Big Bang, it is not a thing behind us. It is a river that carries us still. And in this river, we are both passengers and poets. You drift now in the direction time has chosen, or perhaps the direction entropy requires. You are not alone. The stars you see are also drifting, the galaxies receding, the atoms buzzing, the universe stretching. And yet, in this great movement, there is rhythm, there is poetry, there is presence. And so, when you ask when time began, you are not only asking about physics, you are asking about beginnings, about emergence, about what it means for anything to be. And maybe, somewhere deep down, you are asking where your own thread begins, how you came to be. Wrapped in this moment, held by this now. You listen to your breath again, and in it, you hear echoes of that first unfolding. The universe bloomed, and so did you. Not all at once, but gradually, slowly, softly, softly, like a thought turning into meaning, like silence turning into sound. You are not separate from time's origin. You are part of it. You are its continuation. And as your thoughts begin to slow, like leaves settling on still water, you wonder what lies ahead in this river. If time had a birth, could it someday have an end? There is something haunting about a ticking clock, not its sound, but the way it marks your vanishing. Each second that passes is a second you cannot hold. You live your life by these tiny vanishings, these slices of now. But what if the second itself is not forever? What if time, which seems so steady, begins to fade at the edges of the universe? You are not falling into darkness now, but into a quiet idea that one day seconds may cease to mean anything at all. In the beginning, time was fast and dense, each second bursting with events. Stars flared into being, galaxies collided, matter danced furiously across an infant sky. But as the universe expands, it cools, it stretches, it relaxes, and in that stretching, time itself begins to yawn wider between moments. It is not your imagination. The clock of the cosmos is slowing. Out here, far from gravitational wells, far from acceleration, time begins to lose its sharp edges. The seconds, human-sized, heartbeat-shaped, become ill-fitting clothes on a universe that is growing cold and still. Already, in the furthest reaches, galaxies have vanished beyond sight, not because they stopped glowing, but because their light can no longer outrun the stretching space. They slip beyond the cosmic horizon, becoming ghosts to our eyes and memories to our instruments. The more the universe expands, the more it isolates itself. Time, in a way, becomes lonely. In the deep future, stars will run out of fuel. One by one, they will flicker and fade. The brilliant engines of light and warmth will collapse into black dwarfs, neutron stars, and black holes, remnants of fire. Not fire itself. In such a future, the pace of change slows to a near stop. No more star births, no more galaxies crashing into one another. Just cold, motionless matter, drifting through distances too vast for meaning. And with less change, there is less time. For time, you remember, is not a ticking clock, but a measure of transformation. If nothing transforms, does time pass? You hover now in the imagined silence of 1 trillion years from now, where the last red dwarf casts a faint, warm glow across an empty field of stars. You feel its warmth, not as light, but as memory, a fragile echo of once mighty suns. This star, too, will die, and then the sky will go fully dark, a darkness not of night, but of absence. Without light, without change, the universe enters a phase called the heat death, a time when everything is evenly spread and nothing new happens. All matter dissolved into simplicity, all gradients erased, no motion left that matters, number, contrast, no clocks. Seconds still exist, in theory, but they have nothing to measure, and so they dissolve into irrelevance. You ask, gently, does time still exist if nothing feels it? You recall how your own sense of time bends with perception. Hours stretch when you're waiting. Years vanish when remembered. The mind can dilate seconds or shrink them to a blink. So too, in the far future, the universe itself may feel like a paused breath, a moment stretched endlessly across silence. Physicists call this a thermodynamic equilibrium, where entropy has reached its final resting state, and there are no usable differences left. Entropy, that slow, crumbling toward disorder, is the great driver of time's arrow. Without entropy increasing, the arrow stops flying. You imagine it now, not a clock stopping, but a clock whose hands move, yet have nothing left to point at. In this timeless future, black holes are the last dancers. Silent and spinning, they swallow what remains. Even light bends into their gravity, curling inward like a secret. But black holes do not last forever. They evaporate ever so slowly, through a process called Hawking radiation, a whisper of quantum mechanics at the edge of collapse. Over unimaginable stretches of time, they lose their mass, they shrink, they fade, and finally they vanish. Not with a bang, but with a sigh. This, too, marks an end. When the last black hole evaporates, when the last proton decays, if protons decay at all, the universe will be left with almost nothing, just cold particles scattered thinly through a vast black silence. Nothing will collide, nothing will change, and so no time will pass in any meaningful sense. You are still here, floating in this idea, and yet you are not afraid. It is not sadness you feel, but a strange peace, as if the universe, having run its course, simply lays down to rest. The death of seconds is not a tragedy. It is a returning, a slow closing of the book after a beautiful story. It reminds you of sleep, the way you surrender the ticking of your day. Not because it is over, but because your body needs stillness. The universe too may need stillness, a kind of cosmic exhale. You wonder, is this truly the end? Or just a transition, one so slow we cannot yet perceive it? Some theories whisper of new physics beyond heat death, of spontaneous rebirths, of quantum fluctuations birthing fresh bubbles of space-time, of new big bangs arising like dew from the quiet. If time died here, could it be born again elsewhere? Could a second, reborn in a new cosmos, tick once more like a heart returning from a long sleep? You do not need the answer tonight. You only need the question. You hold it gently, like a candle. In the dark, the death of seconds is not your death. It is not your ending. It is a distant idea, a shadowed possibility. You still live in a world full of ticking, of breath, of motion, of thought. And so you turn back from that distant silence, carrying with you a reverence for the fleeting. Every moment you live is radiant with rarity. You exist in the golden age of time, when seconds still matter, when the stars still shine, when memory still walks beside light. As you close your eyes, you no longer fear the quiet ahead. You simply drift with it, as all things must. Because even if time ends, the stories it carried, your laughter, your wonder, your quiet listening were once real, and in the vastness of all that was, they mattered. Somewhere ahead, another question waits. If time can die, can it be reversed? You begin to wonder, not how far time stretches forward, but whether it might curl back on itself, not as a metaphor, but as a physical path. The question drifts into your thoughts like fog. If everything is made of motion, and motion obeys rules, could those rules ever run in reverse? You listen now to the soft hum of your own memory, each image sliding back into your past like film rewinding. But rewind is an illusion of the mind. In your body, in the molecules of your breath, time still flows only one way. Your thoughts may leap backward, but your cells decay forward. Yet the universe, beneath its surface, doesn't seem to care. The laws that govern particles, quantum equations, scribbled in the fabric of reality, are mostly they work the same whether time moves forward or back. If you watched a single electron bounce around a field and reverse the film, you wouldn't know. The dance looks the same. The laws don't object. In theory, you could run the universe backward and the math would still hold. But something doesn't feel right, does it? Because your tea does not unmix once stirred. Heat does not flow from cold cups to hot hands. Ashes don't rise to become logs. Somewhere in the middle of this symmetry, there is an arrow not drawn by the laws themselves, but by something deeper. That something is entropy. You've felt it before, like a breeze through your lifetime. Entropy is the measure of disorder, and the universe loves disorder. From the hot, tidy beginnings of the cosmos, everything has been slowly unraveling, spreading, blurring. Order becomes chaos, but never the other way around, not without effort, not without adding energy, you begin to see that the arrow of time is not sewn into physics, but into probability. It's not that the laws demand time to go forward. It's that forward is vastly more likely. A cracked egg has a million ways to stay broken, and only one way to return to the shell. The past is unlikely, the future abundant. That is why time flows the way it does. Still, some whisper of backwardness remains. You imagine a universe with perfect memory of every motion, where no information is lost. Could it run in reverse like a film, frame by exact frame? Some physicists believe that if you knew the exact position and momentum of every particle in the universe, you could rewind reality, but this is not just impractical, it is impossible. Quantum uncertainty blurs the edges. You can't know everything at once. The act of looking disturbs the very thing you seek to see. And yet, in this dance of mystery, the question stays with you. Can time ever flow backward? Not in theory, but in experience. Could your future become your past? Could light and thoughts unborn push backward into now? There are strange hints in physics that time might be more flexible than you think. In certain quantum experiments, particles behave as if future measurements influence the past. In entangled states, one half of a particle pair responds instantly to what happens to its twin, even if they are separated by light. Some interpretations say this means information travels backward in time, folding the timeline in strange loops. Others say it's just math, a trick of perspective, but you begin to feel something else, a sense that time is not one river, but many. That maybe, beneath the surface of your one-way path, there are eddies, currents, crosswinds. You think of black holes again, those strange mouths of space where gravity bends time like a ribbon. Near their edges, time slows to a crawl. Could it ever reverse? Could something fall in and come out before it entered? Not according to general relativity, which holds time tightly in one direction, but in quantum gravity, a theory not yet born. The rules may differ. Then there are closed time-like curves, paths in curved spacetime that loop back on themselves. Solutions to Einstein's equations allow for them. You could, in theory, ride one and meet your younger self. But such loops bring paradoxes. If you change the past, do you still have reason to go back? These contradictions seem to shut the door on time travel, and yet they tempt the imagination. You remember that the universe doesn't promise to make sense to your storytelling brain. Nature is not bound by your need for clean beginnings and endings. In the multiverse view, where every quantum event splits the universe into many paths, maybe one branch moves backward, maybe time there folds into itself like a breath drawn and never exhaled. But would it feel like time to those inside it? Or would their past feel like your future, their dreams unwinding into memory? You don't know. You don't need to. Because what you realize is this: even if time cannot flow backward, your thoughts can. Your mind is a backwards traveler. It remembers, it replays, it mourns, it longs. You carry your past not as data, but as feeling. And in this feeling, you sometimes touch something timeless. Maybe that's what the backward flow of time really means. Not clocks reversing, but awareness deepening. Understanding, traveling inward. Seeing not just what was, but what it meant. So no, your tea won't unmix. Your heartbeat won't pause and retreat. But the echoes of your past live on in you, not as events, but as texture. And in remembering, you keep the past alive. Not in physics, in poetry. You drift now into stillness, letting go of the need to know. Time may never truly reverse, but it may someday dissolve, like a wave meeting the shore. And when it does, you wonder, will there be anything left to feel the absence of time? Or will that, too, slip backward into silence? You have wandered far across, seconds stretched and curved, through particles that jitter with clocks hidden in their spins, past the cosmic clockwork that winds galaxies apart and the deep gravity, wells where time slows to a hush. Now, at the end of this trail, you stand not before a conclusion, but before a question with no edges. What if time itself is only one layer of reality, and underneath, beneath all the ticking and turning, there is something timeless? You close your eyes and imagine a still point. No before, no after, not frozen, not paused, but free. Like the moment between inhale and exhale, not a gap, but a presence. A moment not waiting for the next. Could such a place exist? In your heart, you feel how you sometimes find it, in awe, in grief, in love. The sense that time has slipped away, and all that remains is being. In physics, this place is elusive. Equations are built on motion, and motion requires time. But some theories suggest that time is not fundamental, that it emerges like temperature, not a thing itself, but a property of many things moving together. Strip the universe down to its rawest math, and time vanishes. What's left is a network of relationships, connections, symmetries, space without steps, moments without markers. In the world of quantum gravity, some physicists write equations without time. They describe states of the universe, not changes in state. There is no ticking inside them, just timeless truths. Could it be, then, that what you call now is not a slice in a stream, but the whole sea scene from one shore? That your consciousness is not moving through time, but filtering the timeless through attention? It is not a new idea. Mystics and philosophers for centuries have whispered of the eternal present, not eternity stretched out, but the intensity of a single moment that never ends. They say this moment is always here, if you can stop running forward or looking back. You are here now, in that quiet. In deep meditation, some people report a melting away of time, not because their minds go blank, but because they widen beyond identity, beyond direction. Time becomes unnecessary, like shoes on the wind. You wonder if, at the end of the universe, when entropy has smoothed all sharpness and every star has burned out, something like that will remain a quiet awareness, without clocks, without decay. In that far future, there will be no heat left to flow, no imbalance to right. Time, in thermodynamic terms, will have no reason to exist. The cosmos will not move, it will be still. But stillness is not nothing. In music, the pause matters as much as the note. The breath between words is what lets meaning in. So you begin to imagine that maybe the final moment is not an ending, but a fullness, like the silence at the end of a song, echoing forever because the listener still listens. Could consciousness survive such a moment? Would there be anything left to remember the journey? Perhaps not in form, but perhaps in pattern. Some theories suggest that information is never lost, not even in black holes. It can be transformed, scattered, encoded in the edges of space. Could you, too, be written there, not as you, but as the ripple your existence made in reality? Your laughter, your questions, your grief, all woven into the great quilt of causality. If time falls away, and all that remains is the memory of what once flowed, Perhaps that memory is eternal. Perhaps it is what you truly are. You breathe in now, deeply, slowly, and feel that your body still obeys time. Your pulse still beats, your lungs still tide. But your mind hovers near something else, the still point, the unshifting center. And in that stillness, there is peace. You are no longer rushing forward, no longer clinging to what was. You are simply here. The past has softened into story. The future has curled into mist. What remains is presence, warm, aware, and resting in the fold between heartbeat and hush. The journey through time has led you back to this, the place that holds all places, the moment that shelters all moments. You do not need to move anymore. You are the witness now, and in your stillness, the universe watches back, not with eyes, but with being. The stars, too, remember you. And maybe, just maybe, in the place beyond time, you remember them.